Okay, it's the student online. It's supposed to be two-way, no? Hello.
Is there?
No, where is the student? How
No,
do I answer?
already asked it in the question, which is already asked in the Google forum, sir.
Yeah, I know, but how do I answer this? Just talk and the candidate is online.
No, sir, it is being recorded in YouTube also, sir, so that participant can view in the YouTube later.
Okay, so question from Mr. Anil Kumar Sharma, genetic information, immune system, saved and static information on both, whereas nervous system information is instantaneous. Nervous system memory is also saved and processed in the sense that there is an output. All of them ultimately have the same logic, that there is input, there is maybe learning in terms of nervous system. In immune also, I do not know whether you can call it as learning, but there is variation in the sense that you can the immune system can interpret different foreign proteins based on what has been learned. Genetic, obviously, mutations are a method of learning. You have changes within the genetic structure and mutations happen, which favorable mutations are allowed to propagate. So there is learning. Nervous system also. Say, for example, what you develop as childhood habits persist in adulthood. So there's also long-term memories which are stored in the nervous system and acted upon.
Okay.
The nervous system also helps in instantaneous maps which are generated and built. In fact, I am frankly I didn't understand the question completely because nothing permanent I didn't understand. So I think it is based on what I might have spoken in the class, but the idea I had to convey was all of these systems store, acquire information, store information, and process information. One. The second thing is learning, as we understand in neural networks, has different meanings in the immune system and genetic system, but it does exist.
31.
So I hope that sort of clarifies the question. They are all information systems. So information systems which have varied time spans. Say genetic information has time spans of millions of years. Immune system also would have time spans of millions of years, but considering that very low organisms don't have dedicated immune systems, it's as a shorter span of time in which it was active. Nervous system, of course, incidentally, the world which you see around is sort of nervous system memory. So when you built a building, the information of building that is stored in the environment. So somebody else through his or her nervous system acquires the memory. So I think that's the concept which I want you to take home.
Over, I think, Sir, is Anil Sharma is our TA?
No, no, he's a student.
Then, Mr. Anil Sharma, you can ask your question or doubt if you have anything. And if there is no questions, and we are planned to wind up in a couple of minutes. Thank you. I think we can wind up. So can you hear me?
We'll wait for some more minutes. The student has just joined back. He was logging back and doing some audio.
Okay, sir, we can wait.
Yeah. He seems to have very slow internet connection. Hello.
Sir, got one question from YouTube, sir. You can check in the chat box.
Possible external. Oh God. Then how is it stored, and if any possibility to modify it externally, not in a destructive systematic. I presume that it is never system information. Simple answer is we don't as yet know how a specific memory is encoded. So I've been telling very broad areas of temporal lobe, hippocampus, and long-term potentiation and things like that. But how is the alphabet A stored in memory? If we don't even have a clue as to how it is. How the shape of A, the sound of A, the motor map, which is responsible for the various kinds of A stored in memory, we have absolutely no clue. So only when you know something, how it is stored, or an approximation of how it is stored, can you even think about changing it either for the good or for bad. And as I understand, till date, it's not a feasible option. It's not possible to do that. We don't see, again, if you look at neural network theory, ANN theory, they have this concept of taking out in between layers of a very large deep network and trying to see how the representations look like. So there is this neural network dreaming concepts. I think you should search out on that, and you'll find ill-formed entities within the middle layers of deep neural networks. So even those, the artificial neural networks, we don't have a physical capacity to intervene in between and do. There are algorithms which govern the entire neural network, but you do not have algorithms or methods which can tackle individual neurons or change individual neurons for a beneficial effect. Of course, you can always change parameters, the weighing parameters and connection parameters, but there are no systematic methods. There are very, very broad-based approaches, say, for example, pruning and what is that? I think in LSTMs, they have this skip layers and things like that. So they are coding, I wouldn't call it as techniques, they are coding hacks which sort of help you improve the network. But you cannot specifically change memory, specifically change something within an artificial neural network. So if you're not able to do that in a completely artificial neural network, it's obviously not at present time feasible to change a natural neural network. I don't know if you have gone through my complete set of lectures. In one of the lectures, I've highlighted the idea of how it's difficult to capture information even from a single neuron. The various parts of a neuron have different state functions. So for example, synaptic, if you have a matrix containing the entire synapses, you would find that the variables keep changing with time. There are similar such variables for the IPSPs and EPSPs generated within the dendrites, the ionic summation which happens in the cell body, the voltages which are generated at the axon hillock, the frequency of the axon potential, the number of jumps which across nodes of Ranvier. So a single axon itself has so much of computing capacity, sort of memory capacity which exists, and so it would be very difficult to duplicate even the state function of a single neuron. So if you're not able to duplicate the state function, obviously it's very difficult to intervene into the state function of a neuron. I think that's a more convoluted answer.
Yeah, good afternoon, sir. Your voice is audible now. There was some technical issue from my side only.
Yes, please do. Please do.
Yes, sir. I just seen the message that you answered a question raised by me.
Yeah.
Can you repeat the?
Yeah, so I was saying that I think you based the question on what I might have told in my lectures, right? So
Yes, sir.
I will try to answer it differently. I mean, in a lecture, you have a thought process. See, my point of highlighting information systems was that there are very different kinds of information systems. See, the nervous system does not look like the genetic system. The immune system is very different from the nervous system and from the genetic system. So they are very different classes of biological information systems. So that was what I was highlighting. But if you look at it, there are so many loops built into it. Obviously, the nervous system runs on genetic code, right? How a neuron is built, how the neural networks are built, how the connections are made depends a lot on the code which is stored within the genes. So that sort of expresses itself. But so they are different from each other. But the purpose of all three things is to acquire information. In genetics, say for example, it is transferred from one generation to another, which is itself acquisition. In immune system, it is from parent to child, and during childbirth, I've not spoken in that detail about the immune system. So there's a lot of training which happens within the child as the child develops. And the nervous system, obviously, you learn different things. I've highlighted simple things like alphabets and language and methods of doing methodologies of doing things, handwriting, for example. So one difference which I've highlighted is the time spans. So genetic information, whatever is acquired, is transmitted only to the next generation. So it can't, it doesn't get replicated within the lifespan of an individual. But across several generations of individuals, you would see changes. That is called as mutations, which is incidentally, I would call it as a type of learning. So that is transferred across generations. So within 100 years, you would find genetic changes which are acquired over 100 years and expressed. Immune system, within the lifespan of a person, it is expressed. I think the coronavirus is an example in which something which the immune system doesn't know how to react to properly. So it's a new virus. So new epitopes are there which are similar to what is existing in the body, but not exactly matching. So that is why you have got people who are susceptible to coronavirus, who people are immune to coronavirus, people who literally die within short periods of getting infected with coronavirus. So that is within a person's lifespan. Nervous system, on the other hand, as I am talking to you, you are learning something new. I am also learning something new. And the dynamic maps are generated from our environment and from our discussion, and that gets updated second to second, millisecond to second, millisecond to seconds to hours together. So time spans are different for genetic, immune, and nervous system this one, but of course there are overlaps. The other example which I was telling is that, say, with our nervous system, we build a house or a building, but that house stays in the environment, and anybody else who is looking at that house may like to replicate it, which in itself is a form of learning. So that's so there are very different manifestations of biological information system: acquisition, storage, and output. So that's what I was trying to highlight in my discussion. I hope that sort of clarifies your question also.
Yes, thank you. Yes, thank you, sir, for detailed explanation. The question raised in my mind specifically thinking about say if you want to develop a neuromorphic computation system. So the compactness is biological compactness is highly appreciable, and your detail about the anatomy of the brain give us how complex and how systematic it is being formed. Another thing is, see, in if we see a computer system, we find one part as a memory and one part as a processor. So in the mind, if we take where is the memory? So if we say, in the computational way, whatever I'm looking at an instant, that is the memory. So if we say in the computational way, whatever I'm looking at an instant, that is the memory. So in the mind, if we take where is the memory? So whatever I'm looking at an instant, if I convert that image into a data, it will be in terabyte. I had read somewhere like this. For instance, a picture with all the features, 3-dimension features, if being stored, it will be in terabytes, because that goes in 0 and 1 only.
Yes.
But the mind do not do like that. Even I can't recall exactly what I have just seen 1 seconds before. You tell us about the sampling of the image.
Yes.
And very less, only the features are being extracted, and
Yes.
the state maps are integrated, and some things goes like that.
Yes. See, again, those are things which we understand. It is like it's like building a straight line, drawing a straight line map between say Delhi and Bangalore. How you go from Bangalore to Delhi by road is, it's a very different story altogether. So what information we have about the nervous system is only about that level. You can say on a map that there is a straight line which connects two places. So the complexity, more than complexity, I think it is the efficiency with it which it saves is phenomenal. But having said that, I spoke about how much of computation, even now I spoke about how much computation happens within a single neuron. We often underestimate the amount of computation which happens. So per neuron, if the computational complexity is so much, okay, I'll give you the other way around. I think in my cerebellar class, I spoke about the number of synapses which exist on a Purkinje cell neuron. It is in several thousands or millions or something like that. Now,
Yes,
one
sir.
single Purkinje cell has the same computational capacity as the most sophisticated ANNs and CNNs which are there. One single cell. So you
Right,
have
sir.
not reached that kind of complexity in ANNs and things like that.
Yeah, there are, so see a single neuron compiling so much EPSP and IPSP,
IPSP, yes.
and it is totally, and it's very dynamic,
Yes, yes.
and it's dendrites, so several dendrites are there, and so much compilation is going on a single neuron.
Yes, yes. Very true.
Yeah.
No, that is because a comment here on towards the engineering side is, the neural ANNs are so inefficient computationally. See, for your entire basics of computer science is about computational efficiency, right? We've got all these algorithm systems which discuss a lot about how much of search parameters are optimized and things like that. But if you look at it philosophically, ANNs are the most computationally inefficient methods of doing something. Of course, it works very well, but it's not very efficient. So therein lies the clue. So each weight and each connection parameter of ANN has to be stored for further computation. The nervous system does not need to do that. It's dynamic. So you develop memory, store memory, and process memory. What you call real time. That makes
Yes,
a lot
sir.
of difference.
Yeah, sir. These ANN nowadays being developed, they are very much expert in pattern recognition, or say
Yes.
classification of very specific task.
Yes.
Yes. Sir, am I not taking much time, because
No, definitely not, because I don't think I have other people waiting. So you please take your time, and I have time today to
Sir,
interact.
there was one in the engineering side books on artificial intelligence or ANN. There are neurodynamics. This the computation methodology of biological computation is discussed as a chapter in neurodynamics. So in this, there is a single differential equation, partial differential equation, single partial differential equation, and all the things revolve about the solution of that equation, and that solution of that equation uh, is also giving some results also coming.
Yes.
But that is again highly simplified mode of a neuron.
Yes.
and even the recent update of the research article, they we are continuing on that partial differential equation only for neurodynamics. So you have any input for the mathematical part of
Okay,
modeling a
so
neuron?
okay, so see, just give me a half a second. One. Not exactly half a second. It was more than 5 seconds. Yeah.
Yeah,
So I have not touched upon computational neurobiology. So there have been two computational neurobiology packages which have been developed some long time back. One is called as a neuron, which is apparently very popular. And
Yeah.
incidentally, I would like you to know that there is a package called Genesis also. So about 20 years back, I used to do some stuff in Genesis, and Genesis has an Indian connect also. There's the dean of NCBS, was one of the original code writers for Genesis. These are packages which are dedicated for that. You know, in say for example in Genesis, you know, you can choose channels and then determine how the channels work. You got squid axon channels, and at neuronal levels you have different kinds of neurons with connects and things like that. Now, unfortunately, that was written in very old, I think it was written in C++, and not much updates have happened subsequently. You need to have, you know, how a language becomes popular, like Python, it becomes popular because people contribute to the development. So that I figure out has not happened much in both Neuron and Genesis. So, but there is nothing much which prevents you from developing. Incidentally, one of the ideas of me taking this course was to encourage people to do that. See, Neuron and Genesis have been there for the past 20, 30, 20, 25 years or something like that. More than 25, it's I think 30 years or something like that. So newer coding techniques, better coding hardware should help you, help you to bridge the gap. Bridge the gap for two reasons. One is to build next generation ANNs, which is one of the ideas of my presenting the biological stuff, like what you rightly told. See, the concept of EPSPs, IPSPs, spatial computation does not exist in any of the ANNs. And whenever I look at videos from the West, university videos, obviously there are these classes which are available online. I understand that a lot of inspiration is obtained when students listen to people speaking in class. So this class was designed so that people who are in the field, you get a feel of what is happening in the biological side and maybe get inspired to develop these kind of packages. I would recommend packages rather than building simple Python programs which do only neuron or muscle, something like that. You build systematically. Ultimately, see, what is a neuron? It's a class. And for a class, you got attributes. What are the attributes? The attributes can be EPSP, IPSP, and action potential and a synapse. So each thing is a class in itself. So synapses contain presynaptic, postsynaptic, and a neurotransmitter. So it's not that very difficult to code if you know good enough coding.
Yeah,
so it's meant to inspire. It's meant to inspire. The course
thank you, sir. You this lectures has definitely inspired a lot. Not only inspired, but had given the in-depth also. I was I was working in isolation on these intelligent machines, but going through these lectures, it's a lot of opportunities are there to work now. So many dimensions are open now. I was normally whenever I used to read any research a research article on space navigation, I think in 2008 when Nobel Prize was given to I'm missing the name of for identifying the direction cell, grid cell, space cell in rat brain. So when I pick up that paper and they were telling about visual cortex, laminar, some vertical and region 1, region 2, I used to take it as a mathematics part. Okay. And I didn't never get it ki ye hai kya, what is actually happening, why they are doing so, and I leave that paper aside. Now after attending your lecture, I am really getting in depth of that paper. Now I am understanding what they are trying to say.
Thank
When
you,
they say,
Anil. You have made
yeah,
my day.
yeah, thank you, sir. You too make our time. I eagerly wait for every week lecture and immediately complete them.
Thank you so
Yeah,
much. It's
thank
nice
you,
to
sir.
hear a very positive feedback, because as in the beginning of the series, I told you, I didn't have a syllabus with me.
Yeah.
I didn't know what all to speak, because if you speak complete biology, you just get put off. It's very difficult to have a fine balance between conveying information and simplifying information. Both are very difficult things to coordinate. So it was an experiment from my side. In fact, you have noticed several kinds of experiments throughout the course. So it's nice to get it's really nice to get a positive feedback.
Yes,
Thank
sir.
you.
Sir, it's first time I explored many NPTEL course. It is first time that like this is being taught. That's good, sir. Because it is now bridging between the engineering and biological science. We are working in isolation, nothing getting what is happening. This why,
Yes, yes.
and we have ideal machine already. We have intelligent ideal machine. Human brain is ideal approach. Even leave 1%, 0.01%, if we can work out, that will be a great thing for for us.
Yes, very
Yeah.
true. So, in fact, in continuing your own thoughts, if we look at it, see, the ANN is just based on this concept of synapse. You get activation
Yes.
function, and you got that is the only one concept, but there are
Yes, sir.
several such concepts across the nervous system. So, in terms of amplification, in terms of analog to digital conversion and digital to analog conversion, see, in the engineering side, I understand that analog computation is completely different from digital computation, and it's a headache to switch between the two.
Right,
But
sir.
biologically, it's the other way around. The brain seems to be loving the idea of analog to digital and digital to analog computation.
Yes, sir. That's why that's very nice to understand now. Earlier it was not clear. Earlier it's neuron is again we assume it as a binary only 0 1, either 0 or 1, either 0 and 1. But now it's now things got clear. That it is analog. Lot of analog is there. Then convert to binary, and then
Yes.
actually in the engineering or the output the work mostly biased processor design memory space, we are biased with this 0 and 1.
Yes, too much bias.
Too
Seriously,
much.
too much bias.
Yeah, because so much development is being done now, nobody can deny, nobody can
Correct.
think away from 0 and 1.
Yes.
So there is no, if somebody will try, its speed will be so less, and then
Yes. No, it is just a matter that I think people are not experimenting enough. They
right.
are experimenting with the same basic assumptions. That 0 and
Yeah.
1 is the only way to go ahead, and let's see how best we optimize after that. But
Yes, sir.
you can step one step further back and then rework the whole thing.
Even that even before joining your class, I was just searching about that also. If some membranes are developed, but I didn't found such membranes like the membrane.
There is this field called, I think it is called neural computing, in which you grow neurons on silicon bases and then try to connect between the two. Somehow it doesn't seem to have picked up as much as it should have. See, there's always this the right people have to come together at the right time at the right place for some
Right.
development to happen. So maybe
Right.
that has not happened. that's
that's missing. Thank you, sir. Thanks again. I have taken your lot of time.
no problem. No problem.
Yeah,
Enjoyed
thank you, sir.
talking to you, Anil, and really nice to hear somebody who has followed through the entire lecture series. I'm
Yeah.
pretty sure many people have dropped down in the beginning because it becomes denser and denser as the course progresses on.
maybe people have dropped, but to be with this class, it's a highly interdisciplinary class.
Thank you. Thanks, Anil.
Yeah. Thank you, sir. Thank you. Thank you, sir.
So do we have any more questions? Rumi Day has asked, I mean, how it is stored and if any possibility to manage. I think I've answered that. I hope I've answered that because the question is not very clear to me. If the person is around, I can answer any clarifications if there are.
No question.
So we'll wind up in 2 minutes.
Yes, sir.
Okay.
Yeah, thank you, sir. I think your time is precise time is. I do have so many queries, but I don't want to disturb you more.
Okay. You can, of course, mail on the platform. I usually do reply within 24 hours.
Yeah, sir. Yes, sir. I put my queries and I got the answers also. Immediately I got the answers.
Right, right. Okay, shall we close?
Yes, sir.
Okay, thank you. Thank you once again for setting up the session. Of course, anybody has queries can always ask questions back to the forum and most of the time are answered. Thank you. I'll leave. Shall
Thank
I?
you, sir.
Thank you.
Thank you, sir.
Thank you.